Assalamualaikum and hi everyone. So my group will be presenting about the total number of passengers of Rapid KL bus in January 2034. My name is Nadia Atika binti Muhammad Asri. So for the introduction, our goal is to analyze passenger data for Rapid KL buses in January 2024. Rapid KL serves 700,000 daily riders across more than 300 routes, with buses running every 3 to 5 minutes at speed of 35 to 35 km per hour. By examining trends using statistical methods like mean and median, we aim to provide insight that can help improve service and enhance community experiences. So, for the data collected, we gathered daily passengers counts for January 2024 to understand usage trends. This data represents the total number of passengers per day, giving us a clear snapshot on how the service is used throughout the month. So, for the frequency table, to create the frequency table, we first sorted the data in ascending order, then we calculate the number of classes and class size. This allowed us to group passengers counts into range and count how many days fall into each range, making the data easier to interpret. Next is step for frequency table. The process for building the frequency table involves several steps. First, we arrange the data, then determine the number of classes using the formula. Next, we calculate the class size and define the class range, such as 65,000 to 70,000. And finally, we counted the number of days in each range to complete the table.
My name is Muhammad Adam Biroslan and I will continue the slide. Step 2, number of classes. To create the frequency table, we start by arranging the passenger data in ascending order. Then we'll calculate the number of classes using k equal to log n divided log 2, where n is 30, resulting in 5 classes. Next slide. Step 3 is to determine the class size, or C. The formula is C equal to upper boundary minus lower boundary plus k. The lower boundary is 65,900 and the upper boundary is 88,120. The number of classes is k, is 5. Okay, let's substitute this value into the formula. C equal into 88,120 minus 65,900 plus k. So the result, the classes of size is 4,444. Let's go to this step 4. We need to find the upper boundary, which is, the formula is lower boundary plus 444 minus 1. So the first class is 89,443. For the second class is 74,444. For the third classes is 79,444. For the fourth classes is 85,444. For the last classes, which is the fifth classes, is 99,444. Okay, let's go to the next slide, which is step 5, frequency of the class range. In this table, we categorize the number of passenger into class range and note the corresponding frequency, or the number of days within each range. For example, for the range 95,000 to 70,000, there are 5 days recorded. For the 70,001 to 75,000, we have 7 days. Moving to 75,001 to 75,001 to 80,000. This range account for 8 days. The range of 80,001 to 85,000 also correspond to 5 days. Lastly, in the 85,001 to 90,000 range, we observe 5 days. The breakdown provides an excellent foundation for analyzing trend and central tendencies in the data. Okay, the next slide is showing table, which is central tendency and dispersion. This table breaks down the dataset for statistical analysis, showing key measures of central tendency and dispersion. The class boundaries define the interval or the number of passengers. Frequency F indicates the number of occurrences for each interval. Cumulative frequency helps track the running total, showing the cumulative count up to each interval. Midpoint represent the central value of each class. Calculation of fx and fx power of 2 help compute measure like the mean and variance. From this data, the total frequency is 30, and key value like mean and standard deviation can be derived, summarize dataset central trends and variability. Let's go to the 4.1, which is measure of central tendency. Measure of central tendency are statistical values that represent the center of typical value of a dataset. This measure provides a summary that characterizes the dataset, making it easier to interpret large dataset like the daily passenger count of rapid KL buses in January. The three main types of average used are the mean, median, and mode.
Hello and Assalamualaikum. My name is Mariana. So, for the mean calculation, the mean passenger count was calculated as the total sum of daily passengers divided by the number of the days with a total frequency multiplied midpoint product of 2,313,732.5 and a sample size of 30 days. The mean is approximately 77,125.42 passengers per day. This provides a clear average ridership figure. For the median calculation, the median gives us the middle value when the data is added. For rapid KL, the median was found using the formula lower boundary of the median class plus position of median minus cumulative frequency divided by frequency multiplied by class size with a median of 76,875.5 passengers. It closely aligned with the mean, indicating a balanced dataset. For the mode calculation, the mode is derived from the most frequent class range using the formula lower boundary plus frequency difference between the model class and previous class divided by sum of frequency differences times class size. Our mode of 76,250.5 passengers highlight areas with the highest ridership frequency, reaffirming the consistency of users. Next, for the measure of dispersion, to understand variability, we use measures like range, interquartile range, and standard deviation. The range of 25,000 highlight the difference between the highest and lowest passenger count. The IQR of 10,714.29 shows the spread within the middle 50% of the data. Finally, the standard deviation of 6,637.22 indicate how data points deviate from the mean. This measure reveals a relatively stable daily ridership. To understanding how data values vary on spread out, we calculate measure of dispersion including first, range, highest value minus lower values, which is 90,000 minus 55,000 so we will get 25,000. This shows the difference between the maximum and minimum passenger count. And 2 is interquarter range IQR equal to quarter 3 minus quarter 1, which is 82,545 minus 75,786.21, so we will get 10,714.29. This measures the spread of the middle 50% of the data.
Assalamualaikum, my name is Firan Alika Ghazni bin Muhammad Ghazali. My student ID is 62050224006 and I'm from F20B. For quantity deviation measures how spread out the data is around the middle 50%. For the rate PKL passengers data, it was calculated as half of the interquartile range, resulting in a quantity deviation of 5,357. This highlights the relatively small variation in passengers number showing stable usage. For the calculation, the formula of quartile deviation is the third quartile minus the first quartile divided by 2. So the first quartile value is 71786.21 and the third quartile value is 82500.5. So the calculation will be 82500.5 minus 71786.21 divided by 2, and the answer will be 5357.145. Okay, for the next one is the variance. Variance help us understand how far the data points are from the mean. For our data, the variance was 44052,631.82, indicating moderate variability in daily passenger counts. This measure provides insight into the overall consistency of bus usage. For the formula variance equals to fx square time divided by n minus average. For fx square, the value is 179,770,565,756.22. For the total data points, n equals 30. For average value is 77125.22. For the step 1 calculation, fx square divided by n. So 179,770,565,756.22 divided by 30 equals to 5,992,352,191.87. For the second step, we must calculate the average square. So the average value is 77125.22 square equals to 5,948,299,560.05. For the last step is to find the variance. Variance equals to 5,992,352,191.87 minus the average square 5,948,299,560.05. So the answer will be 44052,631.82. For the next one is the standard deviation. Standard deviation derived from variance tell us the average distance of the data points from the mean. Here the standard deviation was 6,637. This moderate figure reinforced that while there are some fluctuation, the passengers numbers remain fairly predictable. For the calculation for standard deviation is square root variance. The square root of variance is square root 052,631.82, and the answer will be 6637.22.
My name is Alia Arisa. Today I will explain to you about this table. It illustrates the interpretation of central tendency for a group data, specifically showing first class boundary, the range value of each class. For example, the first class boundary is from 64,499.5 to 70,000.5 and so on. For second frequency, the number of observations that fall within each class. For example, the first class 64,499.5 divide 64,499.5 minus 70,000.5 has five observation. Third, for cumulative frequency, the cumulative total of frequency as you move down the table. For example, for the first class, the cumulative frequency is 5. For the second class, the cumulative frequency is 12, which means 5 plus 7, you will get 12. Then for the midpoint, the central value of each class boundary, it is calculated as lower class boundary plus upper class boundary divide 2. For instance, for the first class, 64,499.5 plus 70,000.5 divide 2, you will get 67,250. I will explain about this histogram graph. This graph combines a histogram and a frequency polygon to show the distribution of rapid KL bus passenger in January. The histogram use bars to display frequency, with the highest frequency is 8 in the interval 75,000.5 to 80,000.5. The red frequency polygon connects class midpoint, highlighting a near symmetrical trend and balanced distribution. Then I will explain about this OGIF. This OGIF represents the cumulative frequency distribution of rapid KL bus passenger. The x-axis shows class upper boundaries, and the y-axis displays cumulative frequency. The steepest rise between 70,000.5 and 80,000.5, with a total cumulative frequency of 30, highlighting passenger accumulation trends. Okay, so for the conclusion, the statistical analysis of rapid KL bus passenger data for January 2024 highlights steady demand for public transportation, a mean passenger count of 77,124 and a median of 76,875 shows stable daily usage, with the most frequent range 75,001 to 80,000 passengers occurring on 8 days. The range of 25,000 and an interquartile range of 10,714.29 indicate moderate variability, while the low standard deviation of 6,632 37.22 reflect minimal deviation from the average, ensuring predictability for operation. The histogram emphasizes the dominance of the 75,001 to 80,000 range, and the frequency polygon shows a near symmetrical distribution. The cumulative frequency curve or GIF illustrates steady accumulation across intervals, confirming balanced demand. Overall, the findings demonstrate reliable performance and help optimize scheduling, resource allocation and service quality for efficient commuting in Kuala Lumpur. And then this is all our reference from our assignment. We have 4 reference. I think that's all from us. Thank you so much.